Hi, this is, I'm doing this little, I'm doing this series on philosophy of mathematics here, and I'm kind of, um, into this big three type of thing. I'm starting with logicism because that was the earliest thing that actually came about. It came out in a couple of different segments. It came out first in, Frege, and through Bertrand Russell and Rudolf Carnap and logical positivism. But and I'm gonna do a few videos or two that have to do with Frege. I do not any longer have the luxury of having to be able to look at the English translations of his Begriffsschrift and the Grundlagen and the basic arithmetic laws. So I guess what I'm looking at here is I'm looking at a few different. I'm looking on back what I have read, and I'm thinking about a couple. The idea of Frege's program through this book here, which I have been constantly using. Thinking about mathematics by Stewart Shapiros, and also I'm using a paper which is by Crispin Wright, who I think called himself a neo-Fregean. He has this paper called "What is the philosophical significance of Frege's theorem," and this is found in the Cambridge Companion to Frege, and in that he goes over the Hume's principle and things like that. And I'm sorry I have to keep these videos in 10 minute segments because this iPod will not upload my videos if they're over that, even though my account is enabled for videos longer than 15 minutes actually. So yeah. So here's what I'm gonna do here. Frege is probably the first notable logicist. I probably shouldn't say that, but he's the one who had the program of building his arithmetic off of logical principles and of axioms. And in this video, this probably will most likely be 2 videos, maybe 3. In this video, I want to talk about Frege and the idea of philosophy of mathematics with respect to the figures of it, as to whether they're realist or anti-realist in ontology and truth value. And I want to talk about that here, and I want to talk about his program. I want to talk about abstraction, and I want to talk about this idea of a logical ontology, because a big debate here was, is there any kind of logical ontology here? And that was an objection to what he was saying here. Now, I have a iPad here, so I'm going to go into Crispin Wright's paper. I have it on my Dropbox here. Okay. First, I want to discuss the idea of truth value and ontology in philosophy of mathematics. If a philosopher of mathematics is a realist in truth value, that would mean that person is a realist meaning he's having argument and believing, and ascribing to some sort of entities that are mind independent. Now, in metaphysics, a realist would be ascribing to properties that are mind independent, and talking about concrete objects that are also mind independent. Now, but if we're in philosophy of mathematics, it's and it's not a big difference here, but we're talking about numbers or mathematical objects. That if you're a realist in ontology, in the philosophy of mathematics, we're talking about you being you're arguing the numbers and mathematical objects and their existence independent of the mind. Now, if you're an anti-realist in ontology, you are saying the exact opposite, in that the existence of mathematical objects is dependent on the mind, and it does not have objective existence. But if we're talking about realism and truth value, we're talking about does a certain mathematical sentence, is it true or false relative to something that is objective, or relative to something that is subjective? And true, so because there are philosophers of mathematics who are anti-realists in ontology while being realists in truth value, because of how you can give a mathematical sentence and it could be true. You can give it it can be bivalent. You can give it a value of true or false. So that's basically what being a realist in truth value is, that there's a given truth or false value on that certain object. Now, now that I've explained that, I want to state, here Crispin Wright, he says that, as do other logicists talking about Frege, they say that he is a realist in ontology and truth value. And first of all, I want to kind of discuss this first. This is Crispin Wright's paper, 7 minutes, on the philosophical significance of Frege's theorem. First of all, we have Hume's principle. For any concepts f and g, the number of f's is the same as the number of g's, if and only if f and g can be put into one-on-one correspondence. The one-on-one correspondence that can also be said as equinumerosity. That for any concepts f and g, the number of f's is the same as the number of g's, if and only if f and g are equinumerous. Now I'm going to be using the word extensions. Now, if we here, let me show you. There's that for any concepts f and g. We're talking about a uppercase F or uppercase G, we're talking about a concept. F and G are concepts. Now, if you see F and then a uppercase F and a lowercase x, for instance, the X is an object. It represents object or objects. So if we see the extension of uppercase F, we're talking about the objects that fall under the concept F, or the number of the concept F. So if we're saying the f and g are equinumerous, then their objects that fall under those concepts are that, and that they're equal, which makes the concepts equinumerous, or into a one-on-one correspondence. Now, for any concept of f and g, the number of f's is the same as the number of g's, if and only if f and g can be put into one-on-one correspondence. Now, first of all, we are talking about this is a certain axiom. This is the mathematical axiom, or this is a logical axiom. And before this, we had the Dedekind Peano famous 5 axioms, and those axioms were they gave laws for natural and cardinal numbers, and they talked about identity and stuff like that. And what happens here is that we have the Dedekind 5, and that gets decreased to 1. I'm going to go to a different video now. The Dedekind piano famous 5, or piano's axioms, I want to pull those up. They're relatively simple. Where do they have that? No, not there. I had one. Where are the piano axioms? Okay. The Dedekind piano famous 5, or the piano's axioms. 0 is a natural number. That's 1. 2. For every natural number x, x equals x. In other words, this is saying equality is reflexive. 3. For all natural numbers x and y, if x equals y when y equals x. I mean, for all natural numbers x and y, if x equals y, then y equals x, or the equality is symmetric. 4. For all natural numbers x, y, and z, if x equals y and y equals x, and then x equals z, equality being transitive. And 5. For all a and b, if a is a natural number and a equals b, then b is also a natural number. This is also saying that numbers are closed under equality. Well, let me go back to my Crispin Wright here. Crispin Wright's paper. Okay. This, we have all these 5 axioms. There were more than 5. There were a lot more. There were more than 5. But these 5 governed. They were mathematical axioms. But Boulos was one who decided to call this Hume's principle Frege's theorem, and that is Hume's principle. Now let me say again: for any concepts f and g, the number of f's is the same as the number of concepts g, if and only if f and g can be put into one-on-one correspondence, or if f and g are equinumerous. Now the question here is, does that really, when I want to think about this, I want to think about, are those 5 axioms, are they basically, do we not even need those because of this principle here? And each of them say something about equality, and that's what Hume's principle does as well. It says, for any constant f and g, the number of f's is the same as the number of g's, if and only if f and g can be put into one-on-one correspondence. And that is essentially what I would call not having to point out each of those qualities of equality. Now, I guess what I really want to get at here in this is I want to get at the idea of what kind of entities Frege is ascribing to. What entities is he looking at? Now, I guess I want to move towards a different thing that Wright talks about. Here's something I want to discuss. We need some distinctions. Most stringently conceived, number-theoretic logicism ought to be the thesis that every truth of number theory is a definitional transcription of a truth of logic. So this is what number theoretical logicism is. It's the thesis that every truth of number theory is a definitional transcription of a truth of logic. So Frege's idea was to build his arithmetic on top of his logical axioms. And then, what is it doing? Okay. He gives a certain example here. Crispin Wright does. Consider the statement. Here's the statement. Hopefully you can see it. The statement that the number of things which are not self-identical is identical to itself. Now this is it's not really this is not a second order logic type of thing. This is a example. It's a statement which is talking about numbers of things. It's not a logical sentence exactly. The statement of the number of things which are not self-identical is identical to itself. Hume's principle, taken as a contextual definition, will allow us to transform this into a theorem of pure second-order logic, second order being predicate rather than sentential logic, to the effect that there is a one-on-one correspondence between the instances of the concept, not self-identical in themselves. So then you can take this statement, the statement that the number of things which are not self-identical is identical to itself, into this sentence of second-order logic. And that's this right here. This has a existential quantifier, and I want to point out first that this sentence of second-order logic states that it has a different requirement here. It requires that the universe has things in it, because that existential quantifier says that sum y equals the number of x, where x is not equal to itself. Now, what the problem here is that what we can't do, he says here, what we can't do is to adopt both points of view simultaneously, taking both that the sense of, saying that this number of this and stuff like that, which is not exactly a second order logic sentence, is defined by Hume's principle, and that it sustains the inference to be. Now, what A is, the sentence talking about numbers of things, not necessarily logic yet. That is essentially talking about numbers, and then via Hume's principle we can transform that into second order logic. Now, he says alternatively, suppose we accept the inference from A to B as a routine existential generalization. Then in that case, A has a content which it appears it cannot have acquired by being stipulated to be equivalent to the relevant second order theorem. So it's saying that we cannot go from A to B because of that little problem where in B we're having this requirement that the universe has things in it being non-empty. And the thing I want to get at here is this principle of abstraction. Now, this principle of abstraction, I think, is let me explain. This is talked about in the Grundlagen. The status of a abstraction principle, of which Hume's principle is one illustration. Oh wait, I'm up to 10 minutes. Okay. The abstraction principle, I think, is better understood with this little example. In a first order abstraction, like Frege's famous example of direction, the direction of line A is identical to the direction of line B if and only if A and B are parallel. Now, Frege would call this an abstractive relation. I guess let's explain by, we have a sentence where concept, the extension A of concept D is equal to the extension B of concept D, saying the direction of line A is equal to the direction of line A if and only if A and B are parallel. Now, that's an abstraction of the principle because the directions is the concept direction D is being abstracted into direction of lines. And what's pointed out here is that in this abstraction is that there has to be a substantial epistemological presupposition. He says this here, that a substantial epistemological presupposition does appear to be made, that we need to know that there really are objects, cardinal numbers, which the truth of instances of Hume's principle demands. We need to know this, it seems, in some fashion, independent of reliance on Hume's principle. Now, I guess I bring up the idea of abstraction simply because I'm interested in thinking about this logical ontology that Frege thinks about. Now, let me go over Hume's principle by way of the way Shapiro looks at it, if I can find that. Where is Hume's principle? Hume's principle. Where is it? Okay, here we go. For any concepts f and g, the number of f is identical to the number of g if and only if f and g are equinumerous. See, I like that because I guess we're talking about here. Let me show that because, I guess it helps me to understand, to see what the concept of uppercase f and the concept of uppercase g and the number of f in the extension A is identical to the number of g extension if and only if f and g are equinumerous. I'm not saying that all the objects that fall under these concepts are equinumerous, that there's the same amount of concepts. The extension of each concept is the same. So my question here is that, well, I guess what I'm thinking about is that in this, every time a Frege or every time Frege or a logicist discusses a concept and an extension of a concept, it's not, we're talking about a concept which is an abstract entity, like for instance the direction of as an abstract concept. That is something that, but I mean we have this abstract concept, and then we have extensions of it, which makes it more concrete. But then we have this epistemological presupposition where that in this little abstraction, like I said, from the abstraction, you go from the sentence where the direction of line A is equal to the direction of line B. Concept D concept D extension A is equal to concept D extension B, if and only if A is parallel to B. That is, what Crispin Wright is saying here is that there's an epistemological presupposition that there's this presupposition is made that we need to know that there really are objects, which the truth of instances of Hume's principle demands. And when you need to know this, it seems, in some fashion, independent of reliance on Hume's principle. In my point about this little discussion about abstraction, I guess what I'm moving towards is discussing this logical ontology that Frege is kind of talking about here. It's what he uses. What he uses as Crispin Wright talks about it. I've seen Stewart Shapiros talk about it, and I think it's very important to think about how a logic of ontology, or ontology of logic, would be conceived, and how we can connect to logical ontology to objective Platonic metaphysics in itself. And I think that's where we get things like the epistemological problems in, like, that's how we get to later beyond logicism. We get like the Quine-Putnam indispensability, and we get things like that, which just cause problems as to the epistemological problem of abstracta, and how numbers are supposed left by like Platonists and even logicists to an extent, as to how they live in this sort of how we have concepts which are abstract, and even things like that are abstract, and how they are in this abstract realm, and how they in this epistemological problem as to how those things, and how math and how those things interact with us, and more importantly for philosophy of mathematics, how those mathematical objects interact with us. So I guess in discussion, I guess Crispin Wright, what he's doing in his paper is he's trying to figure out what's significant about Frege's theorem. Frege's theorem being, the Hume's principle. That's what Boulot said to call it, but that's what given. Wright's goal is to look at how Russell showed the failure of basic law 5, and thus the failure of Frege's whole system, and then he wants to look at that and see where the Neo-Fregean has to go from there, and see how what options are left, and that is considering the Caesar problem, which is the problem how we can't really show inconsistency of issues like how the number 1 is identical to Julius Caesar. That's a different problem, but that's what Wright's goal is to do in that paper, is to show philosophical significance and then show what's left of it, given Russell's paradox. So I guess, but what I want to think about is, I want to think about how Wright discusses abstraction. He discusses abstraction by way of how we can reconceptualize the concept of direction in the line A, and see how that's equal to the concept direction with line B, and we can have those concepts and how we can reconceptualize that into those, and how that sentence being true by virtue of reconceptualizing that into the lines A and B being this idea of parallel, and rather than taking the concept direction of into making that just lines. That is essentially essentially abstraction. That's how we can go from simple lines into having a concept of direction. But I guess what we get from that is we get these. This is shows how Frege was a realist in ontology. It shows that in one way, but it shows how we can go from one simple notion into these concepts, which, not only can we show from that little direction, Frege's famous direction idea, how we can show how we can go from simple lines to actual concepts being formed, as well as we can go from concepts being formed down to mere concreta. But I guess I think that the little idea of abstraction shows. Wright is going for bigger goals, but what I'm concerned with is what would a logical ontology be? Is how would that work? And Wright proposes this objection to Frege. Wright proposes this objection to Frege's system, saying that Frege is saying that logic building arithmetic off of logic isn't good, because it's essentially the objection that logic is not, or that you can't be a realist in ontology while having this, because there's this epistemological problem and such. But Frege shows that with logic, and it's been shown how you can go from Hume's principle to how we can take Hume's principle and take a numerical sentence and put it into second order logic. That's been shown, and the way I see that is that we have in arithmetic. From this, I see that there's, I guess there is in a sense there's abstract numbers, and I'm not trying to argue that. I'm just trying to say that showing this, it shows that, in my opinion, it shows that logical objects are, in a sense, I guess what Hume's principle shows that second order logical objects and logical sentences can be connected to numerical sentences and numerical objects. So that shows to me that there's a certain kind of logical ontology. There's a logical ontology of concepts, because those concepts are formed by objects, and the sets and classes that are in philosophy of mathematics and logic, that comes from objects. It comes from mere objects being grouped into concepts and classes and sets. So I guess my point in this whole video is that for looking at Frege and his predecessors, you can see that logic is not just a method of how to go about arguing things. It's not a method of how to go about saying certain things. It's not a method of it's not merely a method at all. I would say that it's a grounds for it's something that grounds everything we say. It's something that in my opinion, it grounds arithmetic to an extent. Now it can be argued. I mean, I think that it would take a lot to say that it would take a lot to say. It would take a lot to argue and like do all the proofs and stuff to show that numbers are reducible to first order or second order logic. But I think it suffices enough to say that Frege shows well enough that there's a logical ontology and that it's within a lot of things that we argue and do. And it's not just a method, but there's something there besides just that. There's something in logic that is a part of everything that we think about, not just mathematics or numbers. So yeah, that's my discussion on that, because I'm interested in that. So I guess if you have any ideas beyond that, please discuss it, because I think that I guess I used to think that logic was just a method or a way to argue correctly, but it's more like the skeleton of everything that we think about, I would say.